Section 6.3 is the third and final method for solving systems, and it's solving systems by elimination, and we split this unit or this section into 2 days. So again, you don't have to write this down, but this is just a reminder of the 3 different things that can happen. Remember, we can have intersecting lines, which will give us exactly one solution or an ordered pair. We can have parallel lines. They give us no solutions because the lines never intersect. Or we can be talking about the same line, in which case we have infinitely many solutions. And the 3 methods, 2 of those we've learned: graphing, which was section 6.1, solving a system by substitution, which was 6.2, and now we're going to deal with elimination, section 6.3. So this is how you solve by elimination, and please write these steps down, as you can refer back to them as you're solving the problems. But what you want to look for are opposites on the same variable. So for example, you want to see a 2x and a negative 2x, or a 5x and a negative 5x. Those are opposites. But we want the same coefficient. Then you need to add or subtract the equations to eliminate one of the variables. Then we plug that value back into one of the original equations to find the other variable, and we write our answer as an ordered pair, just as we have in the previous 2 lessons. So let's solve by elimination. Remember, first we need to look for opposites. And in front of the x we have positive 1s, but in front of the y's we have a positive 1 and a negative 1. So this is the variable that we're going to look to eliminate when we add the 2 equations together. So when we add x plus x, we get 2x. But a positive y plus a negative y is going to eliminate. Bring down your equal sign. 1 plus 3 is 4. Now you can see we have an equation with one variable, and we simply just need to solve for x. So we divide both sides by 2. We get x equals 2. So the first half of our answer is 2 comma something. And then remember, we always have to plug that value back into one of the original equations so that we can solve for y. So I'll plug it back into the first one, into the x plus y equals 1. So I'm plugging 2 in for x, so that's what x equals. Subtract 2 from both sides, and we get that y equals negative 1. So our ordered pair answer, where these 2 lines would intersect if we graphed them, would be at 2, negative 1. The elimination method is probably a little bit easier than substitution. You'll probably like this method a little better. And remember, when it comes to the standardized, the ECA test, they typically do not require you to solve it a certain way, so you get to choose. So here we have 3x plus 5y equals 15 and 2x minus 5y equals 10. So you can see that we have opposite coefficients on the y's. So that's the variable that's going to eliminate. We're going to add the 2 equations together. So 3x plus 2x, that's 5x. The y's eliminate, and we get 25 on the right, 15 plus 10. Divide both sides by 5, and we get that x equals 5. So the first half of our answer is 5 something, and we need to plug that answer back into one of the original equations. And I'm going to plug it back into the first one. There's really no preference here. So 3 times 5 plus 5y. So I get 15 . Now we subtract 15 from both sides, just like you would solve any other equation for the variable. We get 5y equals 0. Divide both sides by 5, and we get y equals 0. Remember, 0 divided by anything is 0. Also remember, we discussed that you could check your answer by plugging that ordered pair into both equations and making sure that it solved both equations. Here we have another example, 4x plus y equals 13 and 3x minus y equals 8. So again, you can see that the y's will eliminate because they have positive 1 and negative 1. So we're going to add the two equations together. 4x plus 3x is 7x. The y's eliminate, and we get 21, 13 plus 8. So we divide both sides by 7, and we get that x equals 3. Now, y won't always be the variable that eliminates, but it's what has eliminated thus far in the examples. So now we're going to plug that 3 back into the first equation. And notice I'm plugging it in for x because that's what it equals. Don't plug it in for y. Y is what we're trying to find. So 12 plus y equals 13. Subtract 12 from both sides, and we get y equals 1. Number 4, we have 3x plus y equals 10, and negative 2x plus y equals negative 5. Now remember, we're looking for the same coefficient but with opposite signs, and we actually don't have that on the x or the y. On the x we have a positive 3 and a negative 2, so we do have opposite signs, but we don't have the same number. And on the y's we have positive 1s. But we can actually correct this so that we can eliminate. Whenever you have positive 1s on both, we can change one of them to a negative, but remember how that's done. And anytime we get rid of fractions, we multiply by denominators when we're getting rid of fractions. Well, just like when we're trying to make something negative, we can multiply by a negative 1. So I'm going to change the first equation to a negative 3x minus y equals 10. And I'm going to bring down the first equation as it is. I'm not doing anything to that one. And now you see I have the y's so that they will eliminate. I have a negative y and a positive y. So I still want to add these together. Negative 3x plus negative 2x, that's negative 5x. My y's eliminate, and I'm left with 5. So divide both sides by negative 5, and I get x equals negative 1. So if you ever have the same coefficient and the same sign, we'll just multiply one of the equations by a negative 1. Now I need to plug that negative 1 in and plug it back into one of the originals. Don't go down here to the equation that you altered. Go back to one of the originals. So I'll just use the first one again. Negative 3 plus y equals 10. I'm going to add 3 to both sides. And we get that y equals 13. And again, you can check your answer by plugging the ordered pair into both equations and making sure that it solves it. Number 5 is similar. 2x plus y equals 7, and negative 3x plus y equals negative 3. So again, we need to multiply the top or the bottom equation by negative 1. Doesn't matter which one you choose, you will still get the same answer. And I'll go ahead and multiply the top to get a negative 2x minus y equals negative 7. And I'm keeping the second equation as is, I'm just rewriting it. So now when I add them together, I get a negative 5x. My y's eliminate, and a negative 10. Well, divide both sides by negative 5, and we get that x equals 2. We want to plug that 2 back into the first equation and solve for y to get the second half of our answer. And we get y equals 3. So these two lines, if you graphed them, would intersect at 2, 3. Number 6, we have y equals 3x plus 9 and y equals 3x minus 6. Now notice these are arranged a little bit differently, but as long as your y's and your x's and your constants are lined up, these are set up nicely for elimination. If you don't have things lined up, sometimes you'll revert back to substitution, but in this case we can still eliminate. So we're going to multiply the top by a negative 1. Notice we have positive 1y and we have positive 3x. So we need to make one of those negative so that they will eliminate. So the first equation becomes negative y equals negative 3x minus 9. Remember, you multiply the negative all the way through. And on the bottom equation, I'm leaving that the same. So now I need to add up the equations and make sure you keep your equal sign where it is. Don't move it somewhere else. So we have a negative y plus a y. Well, the y's are going to eliminate. That leaves me with a 0. Notice though what happens with the x's. The x's also eliminate. And I have a negative 9 minus 6, or negative 9 plus a negative 6, which is negative 15. Now if you go back to the slide, second slide I believe, that talked about the 3 different possibilities, when you lose your variable, you're either left with a true or a false statement. This happens to be false, which means we're dealing with parallel lines. Parallel lines never intersect, so we get no solution. And this is the answer I'm looking for instead of the ordered pair. Not the word false and not the word parallel lines, but no solution. And then finally, example 7, we have a half x plus y equals 9, and 2/3 x minus y equals 5. We are set up here to do elimination already because we have a positive 1 in front of this y and a minus or a negative 1 in front of the second y. So we just need to add the 2 pieces together. So what we first need to do is add a half and 2/3. So 1/2 plus 2/3. And if you have to do some longhand over here, we need to get a common denominator, so that would be a 6. So that's 3/6 plus 4/6, or 7/6. So we get 7/6x. The y's eliminate, and we're left with 14 over on the left, or the right. Then we need to divide both sides by 7/6. Remember that dividing by a fraction is the same as multiplying by the reciprocal. And we can do some cross-canceling here, and we get that x equals 12. Now, if I went too fast on that for you, I'll go through it again. But you add the 2 fractions together. We need to get a common denominator. And then when you have 7/6 times x, we need to divide by 7/6, both sides. And that's the same as multiplying by the reciprocal, so you can see how I took the reciprocal and multiplied. And then I did some cross-canceling. The 14 and the 7 can reduce numerator and denominator to 2/1, which gives me 2 times 6, which is 12, over 1 times 1, which is 1. 12/1 is just 12. And now I need to plug that 12 back into the first or second equation. I'll pick the first one. Typically I pick the one that has the positive variable I'm trying to solve for. You could plug it into the second one, but then at the very end you end up having to divide by a negative, and I just cut that step out by picking the one that has the positive y. So a half times 12 is 6. We subtract 6 from both sides, and we get that y equals 3. Now, another option for this problem, and I'll just show you the first part of this in purple. You could multiply the first equation by 2 and the second equation by 3 to get rid of the fraction, but remember you have to multiply all the way across. So that would give us x plus 2y equals 18, and then it would give us 2x, don't forget that number up top, minus 3y equals 15. Now, if that was your thought process, notice we've run into some trouble here, because now what we don't have opposites here or here, and we'll actually talk about how to work with that tomorrow in the second half of this lesson, when you don't have the same coefficient on either variable. This is still solvable, but even though it's a fraction, it's really easiest in this case to keep it as the fraction. So the answer here is 12/3. In class, we'll work on worksheet 6-3A.